Okay, this is my explanation for problem set 3, task 1. I'm going to break down this problem set and explain all the things you have to do. So, at the end of the problem set, we have some testing code that will call your tree function multiple times to draw this lovely orchard. And that's what we'll be doing in this task, is using turtle code to draw trees. We'll also be making that code into fruitful functions so that your trees return values in addition to drawing. And this is more practice with functions. This is not a task where you have to use the new material on booleans and conditionals. So here is what you need to build this single tree, which has a main trunk here and then 4 different branches. And each branch has 3 different twigs. And each twig has 2 leaves. And you can see here that there's a sort of structure to this tree where multiple similar elements are repeated. Guess what? Functions are good for capturing and replaying the same behavior over and over again. You'll also notice that the leaves of this tree are all different sizes, and that will become important in a moment. Now, there's a show tree testing function that we provide for you that will draw this picture. Don't get confused. If you just call your tree function right in the shell, this is what I would expect to see. So don't worry about making the tree stand up. You have to sort of turn before you draw the tree if you want it to stand up. It always goes in the direction the turtle is facing. All right, there's several subtasks that you should do in order. And remember that every function you write should be documented. This is just a blanket thing that will keep being true throughout the rest of the course, right? Write those doc strings at the beginning of each function. So we have a whole diagram to show you the different parts of the tree and how large they should be in relation to each other. And there's also a set of rules for that I'm going to read through. So color, there's an argument that specifies the color of the tree. That's going to control the color of the branches. Now, notice that in this diagram, I haven't shown the leaves to simplify things, but we'll get to those in a second. There's a provided function to draw the leaves for you. So the lengths. The third argument specifies the length of the first line that's drawn. That's the trunk length. So in this example, it's 160. And the length of each of the 2 middle branches, so these 2 branches are longer than these 2 branches. That length is going to be 3/4 of the length of the trunk. So if we have 160, 3/4 of that is going to be 120 for each of these branches. Then the length of the 2 outer branches is the branch ratio, which is another argument, times the length of the inner branches. So here our branch ratio, the last argument, is 0.8. That means that our outer branches are going to be 0.8 as long as the inner branches. So 96, which is 80% of 120. Right. The length of each middle twig. So now I'm talking about the 3 little twigs that come out of each branch. That length is 3/4 of the length of the branch that it's coming from. So 3/4 of 120 is, hold on. Right. 3/4 of 96 is 72, and 3/4 of 120 is 90. Sorry about that. Okay. So again, the same ratio of 3/4 for the middle twig. And then the lengths of the outer twigs, the twigs on either side of the middle twig, are the middle twig times that last argument, which is that branch ratio or twig ratio. So in this case, 0.8 of 72 is 57.6 for the outer twigs. 0.8 of 90 is 72, the same number we got for the center of the side branches. All right. The leaves are not shown, but as you might be able to guess, the base length of each leaf is 75% of the length of the twig is attached to. So as we go from the trunk to the center branches to the center twigs, we multiply by 0.75 each time. And then when we're doing the outer branches or the outer twigs, we multiply by an additional ratio that is determined by a parameter to the function that allows us to control the shape of the tree a little bit. All right, how about the angles between things? So The 4 branches coming out of the trunk are symmetric around the line made by the trunk, and they have an angle of 40 degrees between each pair. And that's the 4th argument of the tree controls the branch angles. So we have a 40 here, so we get 40 degrees, 40 degrees, 40 degrees between each of these pairs of branches. All right, and then the twigs from each branch have an angle of separation of 3/4 of the branch angle. So since that was 40, then the twig angle is going to be 30 degrees. And the twigs are drawn 30 degrees left, 0 degrees, 30 degrees right, relative to the direction of the branch. The angle between the first and last twigs is 60 degrees, right? So this is part of the diagram is showing that. And the leaves are not shown again, but they are also drawn 30 degrees to the left, 30 degrees to the right of the twig that they're attached to. This 30 degrees does not depend on the branch angle argument. It's just always 30 degrees. Okay, pen sizes. So how thick are the trunk and the branches? The diameter of each branch is 0.6 or 3/5 of the base trunk size, and the size of each twig is also 0.6 of the branch size. So again, we're multiplying by 0.6 each time. So with a base size of 25 in this example, we have branch sizes of 15 and twig sizes of 9. And it's shown here over in this part of the diagram where it says pen size. All right, so that's all of the information you need to construct your trunk, your branches, your twigs, and make sure that they're laid out according to these various arguments, right? So we can control them with these different arguments. Okay, now for the individual subtasks, these are the detailed directions on how you're going to draw each part of the tree. So first, you should build the twig function. We're going to go from the smallest pieces up to the larger pieces. It takes 3 parameters: the tree color, the twig diameter, and the twig length. Just has to draw a straight line with that color, the pen size, and the length, and then return to where it started. But it has to draw 2 leaves at the end of that line. All of the functions in this assignment must leave the turtle in the same position that it started in, similar to what we did with the monsters last time. Here's a picture for a specific set of arguments, and you can compare this to what you get. The turtle in this picture is green because it just finished drawing the leaves, right? It draws the trunk first, then the leaves, then goes back to the start. Your twig function must also be fruitful. So in addition to drawing this stuff, right, which counts as a side effect, it has to return a value. And the value it must return is the total area of both of the leaves that it draws, accounting for their random sizes. So the leaf function that we've provided for you is random. It's called random leaf. You tell it a base size, and remember that base size should be 75% of the length of the twig that you're drawing. And it actually randomly decides up to between 90% and 110% of that length for the size of the leaf. It's actually the length of the leaf from base to tip. And then that random leaf function returns the area of the leaf that it drew. So you give it a size, it randomly shrinks or expands that size a little bit, it draws a leaf, and then it tells you, here's the area that I actually drew. So what you need to do is then capture those results in your twig function, right? We talked about this don't waste fruit principle. If we're calling a fruitful function, like random leaf is, then we better store that result in a variable. Basically add those 2 results together from the 2 leaves that you draw in order to make your twig function return the total area of both leaves. And I'm just going to refresh the page right here so you can see the update that we just put into place, this magenta text here. The left-hand leaf must be drawn before the right-hand leaf. And you can see how they overlap, that this right-hand leaf, if we're looking sideways, was drawn after this left-hand leaf. So if you don't draw them in the right order, you won't get the correct result from the randomness. The testing code that we've given you includes a function call for this random.seed function. And that function is a little bit complicated, but it basically freezes the randomness in place so that even though we're still getting random values, it's going to be the same set of random values and the same order every single time that we call random seed with the same value to seed the randomness. And so that means that even though it's random, you should be able to test it and get exactly this result. 3,826.620136228513. That should be the exact result you get. And here's even some example output of what it should print, because that turtle bead stuff always prints stuff when it runs, including that total area value again. So you should be able to check your twig function and make sure that when you give it the arguments specified up here, sienna for the color 9 and 90, 9 for the width and 90 for the length, you should get exactly this printed output. Remember, there's that diff checker website that you can use. I think it's linked from problem set 1 task 3 to check whether the output that you're getting is exactly down to the character the same as the output that is expected. So that's the first subtask is twig. Once you have your twig working, you can move on to branch, which needs to use twig to work, right? Because the branch has a main branch and then 3 twigs. So the branch function always draws a line and 3 twigs, right? And it takes 5 arguments. And here they are. The tree color, again, specifies the color. The branch diameter specifies how thick it is. The branch length specifies how long it is. Same 3 parameters as twig has. And then it takes this twig spread, which controls the angle between each pair of twigs. So in our example before, that was 30 degrees. And twig ratio, which is the ratio between the lengths of the outer twigs and the length of the central twig, right? And we said that was 0.8 in our example. So the length of the central twig is 75% of the branch length, as I already discussed, and the length of the outer twigs are that same value times whatever the twig ratio value is. Could be a ratio that's more than 1 to make them longer, actually. The pen size for all 3 twigs is 3/5, so this is sort of repeating the instructions from before, just to sort of keep things all in one place as you're working through. And the 2 side twigs are rotated according to that twig spread value. So you must use the twig function to draw the twigs. You can't like copy paste that code or something. That would be sort of foolish and unnecessary, but also is not allowed. So you have a function that draws twigs, use it, right? And guess what? That function is a fruitful function that tells you the area of the leaves that it drew. Branch also has to report the area of all 6 leaves that its twigs draw, so it had better be recording those results. There's another update here in this magenta text that was just pushed, which says that you have to draw the twig starting from the left-hand twig and proceeding to the center twig and then the right. And in this image, again, the slight overlaps here are a hint that that is the correct order to draw things, right? These were drawn starting, again, looking sideways from the left, center, right. Otherwise, these overlaps would have looked a bit different. So here's what that should look like. And again, here's some example inputs, and here is exactly what should be printed. Obviously, this is long and detailed. I recommend you use that diff checker tool if you want to check against this whole input, or you can trust that if you get the area right, then it should be correct, right? And again, you should be able to get this specific value for the area, even though we're using randomness, because in the testing code, we included a random.seed. Please don't comment out parts of the testing code, other than you can comment out a whole test for something that you're not working on right now. But if you say, leave the random.seed function call commented out, you'll get different results every single time you run it. Or maybe if you leave the random.seed commented out, but have the random.seed commented in from another test, you'll get the same results each time, but they won't be correct. If you're not getting quite the right results, but your drawing looks correct, double check the order in which you draw the branches, because that's this new requirement. And double check that that testing code has the seed function call that's next to the call to branch commented in correctly. All right. Last subtask is the tree. So we have the branches, we have the twigs. The tree works kind of like a branch, except that instead of drawing twigs, it draws whole branches, right? So this is the power of functions. We have a function for a branch. We want 4 branches. Great, call it 4 times. So 5 parameters, tree color, trunk diameter, trunk length, branch spread, branch ratio. You'll notice these are exactly the same parameters that the branch is getting. They control exactly the same things. How far are the branches spread out? What's the ratio between the longer inner branches and the shorter outer branches? There's a big difference that we have 4 branches instead of 3 twigs, but it's not a huge difference. Just like branch and twig, we have to return the total area of what we draw. And guess what? We're going to have to make use of those fruitful branch functions that we're calling to capture their results so that we can return that total across all 4 function calls. Okay, this part is a repeat of the stuff I went through before about the branch length being 75% of the trunk length for those 2 inner branches, and for the 2 outer branches, it's that same value, 75% of the trunk length, but multiplied then by that branch ratio, which is one of those arguments. The diameters are 3/5 as large as the trunk's diameter. That's the same for the inner and outer branches. The angles are the branch spread between them, right? And here it's important, the twig spread that you give to the branch function is going to be 0.75 times the branch spread argument. So if our branches are spread 40 degrees apart, our twigs will only be 30 degrees apart. It's also worth noting, right, in this magenta update text that you have to draw the branches from left to right. And finally, I'm not sure, there we go. So the twig ratio, or the branch ratio argument here that you receive in tree, you're going to pass that unmodified straight on to the branch function. So if the tree gets a branch ratio of 0.8, then the branch will get a twig ratio of 0.8, the very same value. Okay, here is what the full tree looks like standing up. We have a show tree function that basically just turns the turtle left, backs it up a bit to center the tree better, and then draws that tree in a more elegant pose for you. Remember, for all of these functions, the turtle should start and end in the same position. So the turtle starts down here, we draw the whole tree, at the end, it gets right back here. All right, so there's some advice on testing here. You can call show tree and show orchard. We also provide tests for the twig and the branch individually. Again, be careful about these random seeds. Only if those random seeds are correct and you draw things in the correct order will you get the correct results. All right, there is an extra challenge if you would like to do extra work. Probably you don't want to do that, and that's totally fine. But the extra challenge is add some flowers or fruit. Make this tree more interesting. So there's some examples here that go a little bit beyond this challenge in changing like the color of the tree or the shapes of the leaves. These examples are actually from an older iteration of the problem set where that was allowed. In this iteration, do not change the leaf design. But if you want to add fruit or flowers, we can click View Image to see these in a larger context. You're absolutely welcome to do that. And there's lots of different things, right? Here's a spring tree, here's a tree with fruit, here's a fall tree, right? You can make it look like lots of different things. So that's it from me for describing this task one. I will record videos for the other tasks of the problem set as well.